Hey guys, it's me, Mrs. Naraki. Sorry I wasn't able to be there today. Hope you had a great spring break. My daughter has got a very high fever, so I'm just going to go through these notes with you. The first part I filled out. What I want you to do is you can pause the video and go ahead and plug in values for x. I already have them right here into the y equals x squared key, or into the function, sorry. And if you plug 3 in and I square it, I would get 9. So that would give me the coordinate 3 comma 9. And then so on and so forth, 2 comma 4, and then the rest. And what you will see is that this graph is horrible, that it will look like a parabola that we've been doing all along, okay? How do I know it's going to be a parabola? Because it's an x squared. If you go down here, as we know, a quadratic function is a function that can be written in this form. And the standard form, well, this is the standard form, sorry, ax squared plus bx plus c. What makes this function a quadratic is the squared term, which is right here, okay? What shape was made? Well, we know that all quadratics look like a parabola, either open up or open down, and it has a squared variable. What direction does this shape open? It opens up, and we know that because of the x squared term is going to be positive. So if we go down here, we talked about domain and range before. Domain is a set of all the x values, okay, and the range is a set of all the y values. So if you think of the x coordinates, it's all the x coordinates that lie on that parabola. So we go from left to right, and there's too many to name. And the range goes from think down to up. So what is the domain of this function, which is up here? The domain of this are all the x values, so we have to use interval notation. All the x values on this parabola go from negative infinity to positive infinity, which is how we label it right here. When we look at the range, all the y values, the lowest y value here is 0. And the highest y values of all the coordinates on this parabola, they're going up towards infinity. So hence, we use a bracket. Remember, we use a bracket on a value that we include, 0 to infinity. We always say that this is the minimum value, and we say that this is the maximum value. Okay, this is the minimum value that y can be. This is the maximum value. The vertex is the point, is the minimum or maximum point where the parabola stops going down and starts going back up, or vice versa. What is the vertex of this function? The vertex is right here. It is the point 0, 0. Okay. And since it is the lowest point on the graph, we call that a minimum value. Okay, so you're either going to pick from maximum or minimum. If it opens up like this, you are going to have a minimum. If it opens down like this, then your vertex is going to be the maximum point. So this is what a maximum point looks like. Okay. The axis of symmetry is just the vertical line that cuts through. If you think of it as folding the paper, if you fold the paper, that crease that it makes along that line, that is called the axis of symmetry. It's always in the equation or in the form x equals. So for example, if we have a vertex at 5, -2, the equation of the axis of symmetry would be x equals 5, because x is, or 5 is the x coordinate. Do you see any symmetry in the warm-up? What is the equation for the axis of symmetry? Well, since the x-coordinate here at the vertex is 0, my parabola would be symmetrical at the line x equals 0. So we go to the back. So we're going to try a couple of these problems together. The graphs are already given to you, okay? So to find the vertex we know is right here, okay? It is the coordinate -2, 1. And it has, this is the minimum value. It's the lowest point on the graph. It's opening upward, so it's a minimum. What is the axis of symmetry? Well, you look at the x-coordinate, and it is the line. It's this line right here. X equals -2. Okay. Does it open up or open down? It opens up. The domain, which are the x values. The x values go from -infinity to infinity. So think about going from left to right. What's happening to the x values? They're going from -infinity to infinity. The range, okay, we have no y values that go beyond this point right here. So the y value is the lowest. Remember, it goes min to max. So the minimum value of the y coordinates is 1. And then the maximum value, the y values are going up to infinity. Okay? So if we go over here, this is the coordinate. The vertex is 3, comma, -1. It's opening upwards, so that's the minimum value. The axis of symmetry, the x coordinate is 3, so x equals 3. It opens up. The domain, it's always going to go from -infinity to infinity on a parabola, if you haven't noticed yet. The range, the lowest y value is -1. It goes from -1 to infinity. If we go to the last two here, the vertex here is -4, -1. Oops, -4, -1. And it's a minimum. And the axis of symmetry goes through this value. So what is that value here? It's x equals -4. It's opening up. The domain, all the x values on the parabola go from -infinity to infinity. And the lowest y value on this graph would be -1, and they're all going up towards infinity. This one's a little bit different because it's opening down, but it's no big deal. It's still the same vertex. It's 4, 1. Remember, it always goes x, y. This is at a maximum point now because it's the highest point on the graph, the vertex is. So we write maximum. Still the same. Axis of symmetry is x equals 4. Does it open up or open down? Open up or down? It opens down. The domain, of course, all the x values as you go from left to right, they're going from -infinity to infinity. But remember, with the range, we go from the minimum value to the maximum value. So the minimum value, we're coming from -infinity. The maximum value, the y coordinate is 1. So we go from -infinity to 1. Okay? So hopefully this made a little sense to you. We will reconvene on Wednesday because Tuesday you have the park test and you will have to meet in room LL6, all of you. Okay? We'll see you then. All right, bye.